Hello friends, welcome to the online education. This is the lecture number 5, subject 503, physical chemistry and analytical chemistry. Now, we have learned about the unit number 4, introduction to complexometry titration. And today we will learn about the principle of metal ion indicator. The theory was principle of metal ion indicator. So now we have learned about the metal ion indicator, and according to EDTA titration, principle of a metal ion indicator can be explained by a following way. We have learned about the principle of metal ion indicator. When metal ion indicator is added in the solution containing a metal ion. Which type of solution? So containing a metal ion solution, and we will edit the indicator. Now metal ion indicator complex is formed. Which type of complex formed? So metal ion indicator complex is formed. So this is the first of all, according to EDTA titration, metal ion indicator is added in the solution containing a metal ions. So metal ion indicator complex is the form, and this is the our general reaction of metal ion indicator complex. First of all, a metal ion is reacted with an indicator and formed a metal ion indicator. This is the metal ion indicator. Now EDTA solution is added in the above solution. So the EDTA, ethylene diamine tetraacetic acid, is added in the above solution. So this solution is a metal ion indicator solution, and we will add the EDTA. Now metal ion EDTA complex is the form. Metal ion EDTA complex is the form. First of all, metal ion indicator solution, and we will add the EDTA solution, ethylene diamine tetraacetic acid, and form the metal ion EDTA complex, and our indicator was free in the above solution. So the above reaction is possible in some condition. Above reaction is possible if the metal ion EDTA complex, our metal ion EDTA complex is more stable than metal ion indicator. Metal ion EDTA complex is more stable than metal ion indicator complex. So thus the metal ion indicator complex is ionized. Our metal ion complex is ionized in the solution, and free metal ion combined with the EDTA to give a new metal ion EDTA complex. Our free indicator is reacted with the EDTA and formed the new metal ion EDTA complex. But is the possible when metal ion EDTA metal ion EDTA complex is more stable than metal ion indicator. Metal ion EDTA complex is more stable than metal ion indicator when this situation is possible. No, and above reaction is possible if the metal ion EDTA complex is more stable than metal ion indicator, and the complex was formed a new our metal ion EDTA complex, and our free metal ion is combined with the EDTA and formed a new metal ion EDTA complex. Now the stability of the metal ion indicator complex is represented by the formation constant. This is the KIN. This is our formation constant. Stability of the metal ion. Which type of ion? So stability of the metal ion is stability of the metal ion indicator complex is represented by the formation constant KIN, which is explained by the following way. So this is our metal ion M plus N. This is our indicator ion minus M, and gives to a reversible reaction and formed a metal ion indicator complex. This is the metal ion indicator complex. metal ion indicator complex is the form. So first of all, our metal ion is combined with the indicator and form the metal ion indicator complex. Now the KIN formation constant KIN is equal to m into IN n minus m upon m plus n and IN minus m. So this is the formula of a formation constant KIN. Now the indicator exists in the two form. Our indicator exists in the two type of form. Our indicator exists in the two form. First of all, IN minus m. This is the IN minus m. Is the first form of our indicator, and second form is MIN minus m. MIN minus m. This is the our second form of indicator, and this is the our free metal ion. So indicator exists in the two form, IN minus m and m into IN minus m, and both the form have a different color. Both the form have a different color because its pH range will also change. Thus, when the IN minus m and MIN minus m, the indicator gives a color change. There is a color change of an indicator. It depends on the values of the formation constant. This is our formation constant. Color change of indicator. It depends on the formation constants. While the types of color, it depend on the pH of the solution. The types of the color is depend on the pH of the solution, and color change of the indicator is depends on the value of formation constant. Now, metal ion indicator is applicable in particular pH range. The metal ion indicator have applicable to our particular pH range. Now we have learned about the example of a iriochrome black tea. The iriochrome black tea is a tri-basic color. It is contain the tri-basic indicator. Thus, the general formula of EBT is H3IN. This is the general formula of the EBT, iriochrome black tea. Therefore, according to the pH, it is ionized. According to pH, it is ionized. So, the ionization process is formed in the following steps. First of all, our general formula of the EBT, iriochrome black tea, H3IN, and pH was 2.3 to 5.3. This is the black red color. Now it will be ionized, and second form was that H2IN minus. So one proton was removed. 5.3 to 7.3 pH range, and the color was red blue color. And then second form will ionized HIN minus 2. So this is the pH range was 7.3 to 10.5, and the solution color was blue. And finally, our third step, IN minus 3. Above pH range is 10.5, and the solution color was red orange color. So this is the tri-basic indicator, and it was EBT, iriochrome black tea. Iriochrome black tea. This is the full form of the EBT, and this is the step of ionization reaction of a EBT in a H3IN 2.3 to 5.3 pH range and black red color. H2IN minus form 5.3 to 7.3 red blue color. HIN minus 2 7.3 to 10.5 blue color, and IN minus 3 above 10.5 red orange color. So this is the principle of a metal ion indicator. Now, so we have learned about the principle of a metal ion indicator. First of all, according to EDTA titration, so the principle of metal ion indicator is when the metal ion indicator is added in the solution containing a metal ions, so form the metal ion indicator complex. This is the general reaction of metal ion indicator complex. Metal ion plus indicator is reacted and formed the metal ion indicator complex. Now EDTA solution was added in the above solution, and metal ion EDTA complex is the form. So this is the general reaction of metal ion EDTA complex form. Metal ion indicator is reacted with the EDTA solution and formed the metal ion EDTA, and our indicator was free. Above reaction is possible. This is the situation, and this is the condition of this reaction possibility. So above reaction is possible if the metal ion EDTA complex is more stable than metal ion EDTA. This metal ion EDTA complex is more stable than metal ion indicator complex. Thus, the metal ion indicator complex is ionized in the solution, and free metal ion is combined with the EDTA and to form the metal ion EDTA complex. This is the new metal ion EDTA complex. Now, stability of the metal ion indicator is represented by the formation constant KIN, which is explained by the following way. Our metal ion is reacted with indicator M plus N plus IN minus M, reversible reaction, and form the metal ion indicator complex, and the formation constant KIN is equal to M into IN minus M upon M plus N and IN minus M. So our indicator exists in the two form, IN minus M and M into IN minus M, and both the form have a different color. When the IN minus M is equal to M into IN minus M, the indicator gives a color change. Because of the color change of indicator, it depends on the value of the constant, and type of the color is depend on the pH of the solution. So metal ion indicator is applicable in a particular pH range. For example, EBT, iriochrome black tea, is a tri-basic indicator of the, and the EBT general formula is H3IN, and this is the reaction of the EBT. First of all, ionization of the EBT. H3IN is the general formula. pH range was 2.3 to 5.3, and solution color was black red color. H2IN minus 5.3 to 7.3, red blue color solution, and 1 proton was removed, and 2 proton was removed, 7.3 to 10.5 pH range, and the solution color was blue, and finally all protons removed, and indicator color is 10.5 range of the pH, and solution color was red orange. So this is the general reaction and ionization reaction of the EBT, iriochrome black tea, and this is the principle of the metal ion indicator.